let's just move on further and talk about some of the trigonometric ratios of some specific angles. So we already are aware about some of the angles in the geometry, where we have constructed the angles as 0 degree, 30 degree, 45 degree, 75 degree, and so goes on. So now here we are talking about the different angles of the trigonometric ratio. So let's just work with them. Let us suppose if I am first of all talking about the trigonometric ratios of an angle that is 45 degree. Let us suppose if I am just finding out the trigonometric ratios if the angle given to us as nothing but 45 degree. So let us suppose if I am just first of all constructing the triangle. So since let us suppose if I am just taking this particular triangle over here, and if this is the angle A, this is B, which is right angle at B, and this is C. So since we know that if this is a triangle and angle B is nothing but is equal to 90 degree, then it implies that, it definitely implies that angle A plus of angle C, or we can say that angle A and angle C should be is equal to each other. So since you can see over here, if this angle is nothing but 90 degree, then we can say this angle and this angle can be equal to each other. So it implies that we can write it over here that if angle B is equal to 90 degree, if angle B is equal to 90 degree, then we can say that angle A should be is equal to the angle C. It should be is equal to the angle C, because since we are taking this particular angle as 45 degree, because since we are taking this particular angle as 45 degree, so obviously this angle would also be 45 degree as well. So that's why we are taking these angles as equal to each other, because we are working with the taking the angle as 45 degree. So if I'm just saying that if we are taking the angle A as 45 degree, then angle C should also be 45 degree, because we know that by the angle sum property of a triangle, the sum of all the angles should be is equal to 180 degree. So if this angle is 90 degree and if this angle is 45 degree, then mandatorily this angle should also be 45 degree, because that's why we are taking the sum over here as 180 degree. So hence if angle A, let us suppose if I'll write it over here, if angle A is 45 degree, angle B is 90 degree, it implies angle A is equal to angle C, which is equal to 45 degree. Now you can see over here that we know about a particular fact that if angle A is equal to the angle C, it implies that the side AB is equal to BC. Why so? Because we know about a concept that side opposite to equal angles, are equal. It means that these two sides are equal to each other. These two sides are definitely equal to each other. Now let us suppose I'm just making this triangle again. Let us suppose if I'm just making this triangle again, because we are just working on the angle A only, that's why I'm just taking this particular angle with 45 degree only. So let us suppose this is C, this is B. So I'm just considering this figure now rather than this one. So let us suppose if we have BC, AB is equal to BC. So if AB is equal to BC, let us suppose I'm just taking this side as nothing but A, and let us suppose if I'm taking this side as B. So if AB is equal to BC is equal to A, then we can find AC as AC square is equal to AB square plus BC square using the Pythagoras theorem. Now let's just calculate the value. AC square should be equal to A square plus A square, which is equal to 2A square. We can write this as nothing but root 2A whole square, and hence AC would be nothing but is equal to root 2A. Means we are getting the hypotenuse as nothing but root 2A. Now let's just find out the trigonometric ratios for the angle 45 degree. So let us suppose if I am just starting with sine 45. We know that sine 45 is nothing but perpendicular by hypotenuse. So perpendicular over here is nothing but BC divided by AC, and this is nothing but A by root 2A. A and A get cancelled with each other. We are getting 1 by root 2 answer. Now let us suppose if I am talking about cos of 45 degree. Cos of 45 degree is nothing but base by hypotenuse. This is AB divided by AC. So this would be nothing but A by root 2A. A and A get cancelled with each other. This is 1 by root 2. Now let us suppose if I am talking about tan 45 degree. Tan 45 degree is perpendicular by base. So this would be nothing but BC divided by AB. So this is nothing but A by A get cancelled with each other. This is nothing but 1. Now let us suppose if I am talking about the cosec of A. Cosec of A would be nothing but root 2, because since we are taking the reciprocal of this one. Now further, if we are talking about sec of A is nothing but root 2. Now further, if I am talking about the cotangent of A, means a cot of 45 degree. So as we are taking A as 45 degree, so this is 45. This is also 45 degree. In place of A, we can write 45. So cot of 45 is nothing but 1. So here we are getting a special result that if we are taking the angle over here as nothing but 45 degree, so sine 45, let us suppose if I'll write it over here. Let us suppose if I'll write it over here, that sine, cos, tan, we have cosec, we have sec, we have cot, and theta, the angle which is nothing but is equal to 45 degree. If I am taking the angle theta as nothing but 45 degree, then for the theta 45, we are taking this particular sine as nothing but 1 by root 2. The value of this one is 1 by root 2. This is 1 by root 2. This is 1. This is root 2. This is root 2. And this is nothing but 1. So this is the trigonometric ratio of the various ratios when the angle given as nothing but theta is equal to 45. So always remember, whenever we are just taking the angle as 45, sine 45 is 1 by root 2, cos 45 is 1 by root 2, tan 45 is 1, cosec 45 is root 2, sec 45 is root 2, and cot 45 is nothing but 1. So similarly, we can also work on the different angles like for 30, for 60, for 90, and so goes on. So let's just see the other trigonometric ratios for the other angles like 30 and 60 and 90, and how we can form a particular table which is all related with the values of the different angles. Now let's just move on further towards the trigonometric ratios of 30 degree and 60 degree. Now let us suppose if I am just taking an equilateral triangle. Let us suppose if we are just taking an equilateral triangle. So let if ABC is nothing but an equilateral triangle. So let us suppose if I am starting with if ABC is an equilateral triangle. It is an equilateral triangle. Then we know that this angle is nothing but 60 degree. This angle is nothing but 60 degree. This angle is also nothing but 60 degree. And let us suppose if I'm just doing a little bit of construction over here, because we just also have to work with the angle as nothing but 30 degree. So let us suppose if I'm just constructing a perpendicular over here, and I'm just constructing a perpendicular over here, and I'm taking it point as nothing but D. So if I'm just taking a perpendicular over here, so I'm just taking this angle as nothing but 30, and I'm taking this angle as 30. So let us suppose if I'm just forming this particular triangle again in this particular manner, because we just have to work on the angle equilateral, and we just have to work on the two different angles, which is nothing but 30 and 60. So this is my 30 degree, this is my 60 degree angle. Now let's just move on further and talk about the two triangles over here. So since you can see the two triangles over here, that is this triangle and this triangle, they would be similar to each other. Why so? As you can see, since this particular angle is 60 degree, and further we have this AB side in both equal to each other, we know that this particular side is equal to this side, and this angle is nothing but a 90 degree. So we can say by the RHS congruency criteria, these two triangles are congruent to each other. So since we can say the triangle ADB is congruent to the triangle ADC, so if the two triangles are congruent to each other, then we can definitely say that if this angle is 60 degree, then this angle is also 60 degree. And if we are just taking this particular side as nothing but 2a, if we are just taking this side as 2a, so this side is also of 2a, and hence BD is nothing but definitely a half of DC. Why so? Because we know that this particular triangle, this triangle and this triangle, they are congruent to each other, and if they are congruent to each other, it implies that BD BD side should be is equal to DC side. BD side should be is equal to DC side by CPCT. BD should be is equal to DC. And if I'm taking the length of this equilateral triangle as particular 2A, so if this is 2A, this is 2A, so definitely BD would be nothing but half of 2A, which is nothing but A. So BD would be nothing but a half of 2A. Since BD is equal to DC, it implies that BD would be nothing but half of BC, and this is nothing but 2A by A. So as you can see, this is nothing but A. So let's just find out or calculate AD over here. So since AD, we can find AD using the Pythagoras theorem. AD's square should be nothing but is equal to AB's square minus of BD's square, which is nothing but is equal to 2A whole square minus of A square, which is nothing but 3A whole square, which is nothing but root 3A whole square. So we can write AD as nothing but is equal to root 3A. This is nothing but root 3A. And since if this is nothing but root 3A, so we can further find out, let us suppose if I'll write it over here, this is root 3A. So further we can find out tan 30, sine 30, 60 and so goes on. So let us suppose if I'm just concentrating in the triangle ABD, let's just calculate a sine of 60 first. Sine of 60 means perpendicular by hypotenuse. Perpendicular is AD, hypotenuse is AB. So this is nothing but root 3A by 2. A get cancelled. This is nothing but root 3 by 2. Now let us suppose if I'm talking about cos of 60. Cos of 60 is nothing but base by hypotenuse. BD by AB. This would be nothing but A by AB is nothing but, as you can see, this is 2A. A get cancelled. This is 1 by 2. And further if I'm talking about tan of 60 degree. Tan of 60 degree is nothing but perpendicular by base. So this is AD by BD. So this would be nothing but a root 3A divided by A get cancelled with each other. This is nothing but root 3. So similarly you can find cosec of 60 degree, which is nothing but 2 by root 3. Similarly you can find sec of 60 degree, which is nothing but 2. Similarly you can find cot of 60 degree, which is nothing but 1 by root 3. Now if I'm just talking about the 30 degree angle, so let us suppose if I'm talking about 30 degree, so for the sine 30, it would be nothing but perpendicular, that is BD by hypotenuse AB. So this would be A by 2A. The answer would be nothing but 1 by 2. And if I'm just talking about the cos of 30 degree, this would be nothing but base, that is AD, by the hypotenuse AB. This would be nothing but root 3A by 2A. A get cancelled. This is nothing but root 3 by 2. Similarly, if I am talking about tan of 30 is nothing but BD divided by AD. So this is nothing but A by root 3A, and A get cancelled with each other. This is nothing but 1 by root 3. And similarly, we can find the value for the cosec 30. Cosec 30 is nothing but 2. Further, we can find the sec 30 degree. Sec 30 degree is nothing but 2 by root 3, and further we can find the cot of 30 degree, which is nothing but root 3. So hence, using this particular result, that if we have taken any particular equilateral triangle, then we can show that the two triangles that are formed over here after the perpendicular, they would be congruent to each other. If they would be congruent to each other, it means that this base side is equal to this base side, and if these two sides are equal to each other, we can represent this as nothing but A. And after that, we can find out the AD by using the Pythagoras theorem. Using the Pythagoras theorem, we can find the value of AD, and after that we can find out the value of sine 60, sine 30, cos 30, and all the trigonometric ratios which are related with the angle 30 degree and 60 degree. And similarly, we can also do this particular thing with the angle 90 degree. So let's just club all these angles together and form a table. Now let's just talk about all the specific angles over here. So let's just see the table of this one. So we are taking the angle as 0, 30, 45, 60 and 90. And in the same way, we are just finding out the values of all the trigonometric ratios for the different angles like 0, 30, 45, 60 and 90. So the table for all the trigonometric values for the different angles or for some specific angles is nothing but this. So as you can see, if we were talking about the angle 30 degree and angle 60 degree. So the values were like a sine of 30 is half and root 3 by 2, 1 by root 3, 2, 2 by root 3 and root 3. Further, sine of 60 is cos of 60, tan of 60 are all these values. Similarly, tan of 45 are all these values, and tan of 90 are all these values. And similarly, the 0 degree angles, for the 0 degree angles, sine A, cos A, tan A, cosecant A, secant A, tan A, cot of A, all these values are for these trigonometric ratios. If we have these different specific angles as 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So you can learn this table in order to solve the questions that are related with the values of the trigonometric ratios when the angle is given to us. So always remember this table for the questions, because the questions would definitely be based on this particular table. So always remember, whenever we are just talking about the different specific angles like 0, 35, 45, 60, 90, the values of the sine A would be like a 0, half, 1 by root 2, root 3 by 2, 1. The value of cos A would be like 1, root 3 by 2, 1 by root 2, 1 by 2, 0. Tan A would be like 0, 1 by root 3, 1 root 3 not defined, and so goes on. So you can also learn this table by the only sine A particular angle. So let us suppose if I am just talking about only sine A trigonometric ratio. So as you can see, the value of the sine A for the specific angle is 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Now just take the reciprocal of all the values of sine A. So means we are just starting from the end of the sine A value, and we are just taking all these values on or forwarding all these values towards cos of A. So you can see the last value of sine A is 1, the first value of cos A is nothing but 1. The second last value of sine A is root 3 by 2, the second value of this is nothing but root 3 by 2. 1 by root 2, 1 by root 2, so the same value, half, and this is half, the same value for the 0 and 0. Means if we are just talking about the values of the sine A, then for the cos A we are actually writing all the values of the sine A but in the reverse order, that is 1, root 3 by 2, 1 by root 2, 1 by 2, 0. And if we just wanted to find out the value of tan A, we can just take the ratio of sine A and cos A. Means starting from the 1, so we have 0 by 1, this is nothing but 0, as you can see. 1 by 2, root 3 by 2, the ratio of both of these is nothing but 1 by root 3. The ratio of these is 1, the ratio of these is root 3, and the ratio of this is nothing but not defined, because 1 by 0 is a not defined value. And furthermore, you can find out the cosec A as nothing but the reciprocal of sine A, sec A as the reciprocal of cos A, cot A as a reciprocal of tan A. So these are all the specific values for the different specific angles like 0, 30, 45, 60 and 90 degrees. So I hope the table of this particular trigonometric ratios of some specific angles is all clear to you.